Determine the remaining sides and the angles of triangle A, B, and C. So we're given side A is 12 meters, we're given angle B is 58 degrees, and we're given angle C, which is 57 degrees. Number 2, we're going to solve the triangle ABC that exists. B is equal to 35 degrees, 24 minutes. Side A is 38.6 and B is 31.1. Number 3, find the area of the triangle ABC if angle C is 134.3 degrees, side A is 47.7 feet, and B is equal to 39.9 feet. Number 6, we're going to find the area of the triangle ABC with side A being 342 centimeters, side B being 238 centimeters, and side C being 429 centimeters. This is an angle side angle, and so we can find the third angle, which is angle A. So angle A is equal to 180 degrees minus 57 degrees minus 58 degrees, and that gives me 65 degrees. So now we know angle A is 65 degrees. So in order to use law of sine, you must have the angle and the side opposite to that angle. So notice we have the information for A, so we can use law of sine, and I'm going to find B. So whatever I want to find, I always keep that on the left upper hand corner, which is the numerator of the left side. So it's B over sine of B is equal to side A over sine of A. So the only information I don't know is side B, so I'm going to plug everything in. So we have B over sine of 58 is equal to A, which is 12, over sine of A, which is 65. We're going to cross multiply and solve. So it's going to be B times sine of 65 equals 12 times sine of 58. And we're going to divide by sine of 65 on both sides. So when I plug this in, I'm going to say B equals, then we're going to do 12 sine of 58, close the parentheses, hit divide sine of 65. Make sure your calculator is on angle, so go to mode and make sure that it's in degree mode, which it is. So we get 11.23 meters. And now to find side C, we're going to do the same thing. C over sine of C, which is 57 degrees, is equal to 12 over sine of 65. That was my information for side A and angle A. Cross multiply, I'm using law of sine again, so that's C times sine of 65 degrees is equal to 12 times sine of 57 degrees. Once again, whatever I don't know, I always try to keep it on that upper numerator of the left-hand side. And I'm going to divide both sides by sine of 65. So we have C equals 12 times sine of 57 divided by 65. And I get 11.10. We were rounding to the nearest hundredth, and that's why it's I did two decimal places. So here we have basically a side-side angle. And whenever we have that equation, we might have two triangles, one triangle, or no triangle. So first we're going to start by solving for angle A. So we have sine of A over side A, which is 38.6. Once again, I'm using law of sine, is equal to sine of B, which is 35 degrees 24 minutes, over the side B, which is 31.1. We're going to cross multiply and solve. So we have 31.1 sine of A is equal to 38.6 sine of 35 degrees, 24 minutes. We're going to divide by 31.1. And now we're going to take the inverse sine of both sides. And when I take the inverse sine of both sides, so we have A equals, now in the calculator hit alpha y equals, so you have your fraction bar. And if you don't have the fraction bar, that's okay as well. You can hit second in sine, which will give you the inverse function, hit 38.6 times sine of 35, hit second angle, get the degree symbol, hit 24, hit second angle, get the minute symbol, close that parentheses, and then we're going to hit divide by 31.1. And if you have the fraction bar, you don't need to hit the divide symbol because it will do it. When you hit that, you get 45.97, so on. We're going to change that to DMS, so we're going to hit second angle again and do the option 4, which is DMS, which is degrees minutes per second, and that will give me 45 degree 58 minute. So that's A1. So A2 is going to be 180 minus the 45 degrees 58 minutes. So we're going to hit 180 minus 45 second angle, get the degree symbol, 58 second angle, get the minute symbol, hit enter, and then we're going to hit second angle option 4. We'll convert it to DMS, so angle A2 is equal to 134 degrees and 2 seconds. Now, I would actually create 2 more triangles right underneath this. So for the first triangle, we're going to use A1 as 45 degrees, 58 minutes. So now we're going to find angle C. So to find angle C1 will be 180 minus angle B, which was 35 degrees 24 minutes, minus our A1, which was 45 degrees 58 minutes. And that will give me, don't forget to make it to DMS again, so that will give me 98 degrees 38 minutes. For angle C2, we're going to say 180 minus our B, which was 35 degrees 24 minutes, minus 134 degrees 4 degrees 2 seconds. Once again, punch that in and then hit DMS, so put it in degree minutes per second, and that gives me 10 degrees 34 minutes. Now we need to find side. So for side C1, we have C1 over sine of 98 degrees 38 seconds is equal to, I'm going to use the given information, which was B. So B was 31.1 over sine of 35 degrees 24 minutes. I'm going to cross multiply and solve. So C1, so we have C1 times sine of 35 degrees 24 minutes is equal to 31.1 sine of 98 degrees 38 seconds. And when I divide both sides by sine of 35 degrees 24 minutes, I'm going to punch that in all at one time. C1 is equal to 53.1. It says round to the nearest tenths. So now we're going to find side C2. So for C2, divided by sine 10 degrees 34 minutes is equal to 31.1 over sine of 35 degrees 24 minutes. Cross multiply and solve. So we have C2 times sine of 35 degrees 24 minutes is equal to 31.1 sine of 10 degrees and 34 minutes, and we're going to divide both sides by sine of 35 degrees 24 minutes. So we have C2 is equal to 31.1 sine of 10 degrees 34 minutes over sine of 35 degrees 24 minutes, and we're going to round to the nearest tenth, so C2 is equal to 9.8. So here we have that the area is half AB times sine of C, so we have that the area is equal to 1/2. A is 47.7 times B, which is 39.9, times sine of 134.3. And so we have that the area is equal to 681 and 1 squared feet. First of all, notice you cannot apply law of sine here because you don't have an angle with the given side. So what we have here is side angle side. So we're going to use law of cosine to find B. B squared is equal to A squared plus C squared minus 2AC cosine of B. So B squared is equal to 8.425 squared plus C is 6.408 squared minus 2 times 8.425 times 6.408 times cosine of angle B, which was 70.57. Find the answer to that, and once you find the answer to that, then we're going to take the square root of that answer. So B squared is equal to, so B squared was like 76.1247366, and when I take the square root of both sides, we have that B is 8.725 round to the nearest thousandths. So now actually I can use the law of sine because I have an angle and I have its opposite side, and I'll find angle C. So sine of C over 6.408 is equal to sine of B, which is 70.57, divided by side B, which is 8.725. We're going to cross multiply. So we have 8.725 sine of C is equal to 6.408 sine of 70.57. We're going to divide by 8.725 on both sides. And then we're going to take the inverse sine of both sides to solve for C. So C equals, hit second invert or sine, so you'll get the inverse function, and then hit your alpha y equals, so you have your fraction bar. If you don't have the fraction bar, just make sure you put enough parentheses in the problem. So we have 6.408 times sine of 70.57 divided by 8.725. Once again, if you're using the alpha y equals, that helps you so you don't have to worry about all the parentheses. So I get C is equal to 43.84 rounded to the nearest tenth, And then to find angle A, we're just going to use the concept of the sum of the triangles add up to 180. So we have angle A is equal to 180 minus 43.84 minus 70.57, which equals, to get 65.59. So here, notice that we have 3 sides. And so we have side, side, side. And whenever we have side, 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 we want to always find the largest angle. But what corresponds to the largest angle is the largest side. So the largest side here is A. So we're going to find angle A first. So to find angle A, you can manipulate the formula for law of cosine. So we have that cosine of A is equal to A squared minus B squared minus C squared all over negative 2BC. So cosine of A is equal to plugging in A, B, and C into the formula. So A is 21.2 squared minus B is 15.5 squared minus C, which is 12.8 squared, all over negative 2. B is 15.5 times C is 12.8. And then we're going to take the inverse cosine of both sides to find A. So once again, if you have the button alpha y equals, you're going to use that because that helps a lot with how to punch things in the calculator. So I'm going to hit my cosine inverse first by hitting second cosine. So there's my inverse button. Then I'm going to hit alpha y equals to get my numerator and denominator. I'm going to type in 21.2 squared minus 15.5 squared minus 12.8 squared. Go in the denominator and type in negative 2 times 15.5 times 12.8. Hit enter, and we get that angle A is 96.6 degrees. And I can use law of cosine again to find the next side, the next angle, but I'm going to use law of sine since it's faster. So we have our angle A and we have our side A, so we're going to find angle B next. So angle B, which is sine of B over 15.5, is equal to sine of A, which was 96.6, over side A, which was 21.2. Cross multiply and solve. So we have sine of B times 21.2 is equal to 15.5 sine of 96.6. And we're going to divide by 21.2. So, and then we're going to take the inverse sine of both sides. So we have that B is equal to, once again, I'm going to hit second sine, so there's the inverse button. And then I'm going to hit alpha y, so then I get my fraction bar. And I'm going to type 15.5 sine of 96.6. Go in the denominator and type 21.2, hit enter, and we're rounding to the one decimal place with the tenth, so it's 46.6 degrees. So angle C is equal to 180 degrees minus angle A minus angle B, and we get that C is equal to 36.8 degrees. So we're going to use the Heron's formula for the area. So we're going to find the semi-perimeter by saying 1/2 of A plus B plus C. So S is equal to 1/2, 342 plus 238 plus 429. So the semi-perimeter is equal to so that equals 504.5. And to actually find the area, now we're going to do the square root of S times S minus A times S minus B times S minus C, so that we have that the area is equal to the square root of 504.5, 504.5 minus 342 times 504.5 minus 238 times 504.5 minus 429. So when I put that in the calculator, if you want, just put in what's under the radical and then take the square root if that's easier for you. But if you put it all in one go, you need to make sure you put parentheses around the whole thing. So I got that the area was 40,614. And it was centimeters, so it's centimeters squared. Number 16, we're going to determine if V and W are orthogonal. Well, if it's orthogonal, then the angle between them is 90 degrees. So we need to find the angles. So we know that V is 7, 4 square root of 2. And the magnitude of V is the square root of 7 squared plus 4 square root of 2 squared, which is equal to 81, and the square root of 81 is 9. And W is equal to 4 square root of 2, comma negative 1. So the magnitude of W is the square root of 4 square root of 2 squared plus negative 1 squared. Punch that straight in the calculator. The square root of 33. So now we're going to say cosine theta is equal to the dot product, which is 7 times 4 square root of 2 plus 4 square root of 2 times negative 1 over 9 times square root of 33. So on the numerator we have cosine of theta is equal to 28 square root of 2 minus 4 square root of 2 all over 9 square root of 33. So we have cosine of theta is equal to 28 square root of 2 minus 4 square root of 2 is 24 square root of 2 dividing by 9 square root of 33. Now, if you take the inverse cosine of both sides of this problem, you get about 49 degrees. For it to be orthogonal, it must be equal to 90 degrees, therefore it's not orthogonal. For the complex number shown to the right, give its rectangular form and the trigonometric polar form with r greater than 0 and thetas between 0 and 360. Notice that this blue line is the imaginary and it's at 20. So it doesn't have an x value, so it's 0 plus the imaginary is 20i, which is just 20i. So that's the rectangular form. For the polar form, we need two parts. We need a radius, so r. So r is equal to the square root of x is 0, your y is 20. So r is equal to 0 squared plus 20 squared, and then taking the square root of that gives me 20. Now, you did not have to do that to find 20. You notice that from 0, 0 to 20, that's 20. So R is 20. You could just count. And you also notice that this angle right here is 90 degrees. So hence we have that it's 20 parentheses cosine of 90 degrees plus I sine of 90 degrees. Number 18. When multiplying two complex numbers in trigonometric form, we multiply their absolute values. In other words, we multiply their r's and we add their arguments or their angles. So when we divide two complex number in trig forms, we divide their absolute values, so we divide the r's, and we subtract their arguments, so we subtract the angle. So on number 18, that's a division problem, so we're going to divide the absolute values, which is 6 divided by 2, and that gives me 3. So we subtract the angles. 210 minus 30 is 180. And now we're going to write this in rectangular form. So we know cosine of 180 is -1 plus I sine of 180, well, that's I sine of 180, 0. And so we have, distributing the 3, we have -3. 3 times 1 times 0 is just 0i. So my solution is going to be -3 plus 0i. Number 20, we want to graph the complex number as a vector in a complex plane. So we have negative square root of 14 plus square root of 14i. We know that this is in quadrant 2. And the reason why we know it's in quadrant 2 is because x is negative, y is positive, and then we can find the angle as well. So if I was to graph this one, it would be in quadrant 2, and x is negative square root of 14. And my imaginary is at square root of 14. And my vector would be right there. Find the sum of the pairs of the complex numbers, and then we're going to graph the complex numbers and their resultant. So we have 3 minus 4i, comma, -3 plus 2i. So if we're adding the sum, it would be 3 plus -3, which is 0, plus -4i plus 2i, which is -2i, and 0 minus 2i is -2i. So that's the sum. Now, the first vector, which is 3 minus 4i, that's at, notice that x is positive, y is negative, so that's in quadrant 4. So 3 minus 4i is in quadrant 4. And then -3 plus 2i, well, x is negative, y is positive, that's in quadrant 2. And their sum, 0 minus 2i, well, that's a quadrantal, so it's actually on the quadrantal angle. So it would be option A. Number 22, we're going to write the complex numbers in rectangular form, square root of 2 CSI of 315. So I would write that the long form, square root of 2 parentheses cosine of 315 degrees plus I sine of 315 degrees. So we have square root of 2. Cosine of 315, you can use the unit circle. That will be square root of 2 over 2 plus I. Sine of 315 is negative square root of 2 over 2. We're going to distribute. Square root of 2 times square root of 2 is square root of 4 over 2 plus square root of 2 times negative square root of 2 over 2i will be negative square root of 4 over 2i. Remember, square root of 4 is 2, and 2 divided by 2 is 1. Minus, once again, square root of 4 is 2. 2 divided by 2 is 1. I, so my final answer is just 1 minus I. Number 23, we're going to find the following power. 4 minus 4i raised to the 6th power. Find the cube root of 125 CSI of 120 degrees, and then we're going to graph the cube root as a vector in complex plane. Number 25, for the point 3, 135 in polar coordinate, plot the point. Give two other pairs. Number 26, we're going to write the rectangular equation of x minus y equals 11. So we're going to write this in trig form. So we have r is equal to square root of 4 squared plus negative 4 squared, which is square root of 32, and we can break square root of 32 up into 16 times 2, which is 4 square root of 2. And my angle, to find the angle, we have tan of theta is equal to negative 4 over 4, so tan of theta is equal to negative 1. So here we have x is 4 and y is negative 4, so we're in quadrant 4. So where that occurs is at 315. So writing this into trigonometric form, we have 4 square root of 2 CIS to the 315 degrees, and we're going to raise it to the 6. So we have 4 square root of 2 raised to the 6 CSI 6 times 315 degrees. 4 raised to the 6 is 4,096. Square root of 2 raised to the 6 is 8. And 4,096 times 8 gives me 32,768. We have CIS. 6 times 315 is 1890. So we have cosine of 1890 degrees plus I sine of 1890 degrees. You could keep subtracting 360 from 1890, so you get 32768, and this ends up being cosine of 90 degrees. That is the coterminal angle, and we have 32,608. Cosine of 90 is 0, plus I sine of 90 is 1. 32,768 times 0 is 0. 32,768 times I is 32,768 I, and that just gives me 32,768 I. So here to find the cube root of 125, so to find r, the cube root of 125 is 5. So alpha is equal to my theta, which is 120 in this problem, plus 360k divided by, since we're doing the cube root, it's 3. So my alpha is equal to 120 divided by 3, plus 360 divided by 3, k, which is 40 degrees plus 120 degrees k. So if k equals 0, then it would be 40 plus 120 degrees times 0, which is 0. So 40 plus 0 is 40. So it would be 5 CSI of 40 degrees. If k is 1, it would be 40 plus 120 times 1, which is 160 degrees. So that would be 5 CSI of 160 degrees. And if k is 2, 40 plus 120 times 2 is 280. So it would be 5 CSI of 280. So when we graph this, we have the R is 5 and 40 degrees. So the first one's at 40. The next one's at 160. And the last one's at 280, which is in quadrant. So here we're given R theta. So 3, 135. We have 1, 2, 3. So the radius is 3 and it's 135, which is in quadrant 2. So we're trying to write other points that relate to 3, 135. We can also find the point by saying x equals r cosine of theta. So 3 cosine of 135. So that will be 3 cosine of 135 is negative square root of 2 over 2. So that's negative 3 square root of 2 over 2. And y is equal to r sine of theta. So 3 sine of 135 degrees, that's in quadrant 2. So sine is positive, which is square root of 2 over 2. So that's 3 square root of 2 over 2. So that's my point, x comma y. So the easiest way to get another point is basically to just find another coterminal to 135. So if I do 135 plus 360, that gives me 495. So another way to write the same point would be keep your radius the same, which is 3, and then 495, which means it just goes around one time, but it comes back to the same point. Another way we can write this is we can go to the angle 315. So right here's 315, but I don't want the point there. I need the point on the opposite side. So if I want to make something on the other side of the angle, then R needs to be negative. And that will bring that point back up. X minus y equals 11. We know x is equal to r cosine of theta minus y is equal to r sine of theta equals 11. Factor out an r, leaving me with cosine of theta minus sine of theta equals 11. And then we're going to divide both sides because we're solving for r by cosine of theta sine of theta. So r is equal to 1 over cosine of theta minus sine of theta. And to graph this, we can just basically graph it in rectangular coordinate system. So when x is 0, so if I plug in 0 for x, 0 minus y equals 11. negative y equals 11, so y equals negative 11. And when y equals 0, we know x equals 11. So when I graph this, I have my point 0, negative 11, and 11, 0. And that's just a straight line. Number 27, x squared plus y squared equals 16. Be careful here. We know that x squared plus y squared equals r squared. So this original problem is x squared plus y squared equals 16. So I can just say that that's r squared equals 16. And when I take the square root of both sides, do not forget plus or minus. So r equals plus or minus 4. Hence, r equals negative 4, comma, r equals 4. And that's just a circle with a radius of 4. So if you go to mark your center, which is at 0, 0, we're going to go right 4, 1, 2, 3, 4, left 4, 1, 2, 3, 4, up 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4, and that's just a circle. Number 28, for the plane x equals t squared plus 2, y equals 3t plus 5, for t is in between negative 4 and 4, we're going to write the ordered pair that corresponds to t equals negative 1. So we have that x is equal to t squared plus 2. When t equals negative 1, negative 1 squared plus 2 gives me 3. And for the y value, it was y equals 3t plus 5. When t equals negative 1, y is equal to 2, so the point would be 3, 2. For the plane curve, graph the curve x equals t minus 4 and y equals t squared, for t being between negative 1 and 1. And then we'll write the equation in rectangular form. For number 30, for the plane curve, x equals t squared, y equals 3t minus 2, for t in between 0 and 4. So create a table between negative 1 and 1. So I put 0 in there. So when I plug in negative 1 for t, for the x value, I get negative 1 minus 4, which is negative 5. And for the y value, negative 1 squared is 1. So my first point on the graph, the first point will be x is negative 5, y is 1. When t equals 0, we have that x is 0 minus 4, which is negative 4. And y is 0 squared, which is 0. So negative 4, 0 will be my second point. And my last point, when I plug in 1 minus 4 is negative 3. And 1 squared is 1. So my point will be negative 3, 1. So when I graph this, here's negative 5, 1, negative 4, 0, negative 3, 1. And it just looks like a little curve like that, and that's it. And to find the equation, we're just going to substitute. So we have that x equals t minus 4. I'm going to solve for t. So when I add 4, we have x plus 4 equals t. Then we have y equals t squared. And I'm going to substitute for t as x plus 4. So here my equation is y equals quantity x plus 4 squared, where x is in between -5 and -3. So the interval here will be between -5 and -3. Make sure you're using the x values to write your domain. Okay, so here we're going to create a table, and remember t here is between 0 and 4. So we can pick 0, 1, 2, 3, and 4 if you like. To find the x, we're going to take the square root of t. So square root of 0 is 0, square root of 1 is 1, square root of 2 is square root of 2, square root of 3 is square root of 3, square root of 4 is 2. For y is 3t minus 2. So 3 times 0 minus 2 is -2. 3 times 1 minus 2 is 1. 3 times 2 minus 2 is 4. 3 times 3 minus 2 is 7. 3 times 4 is 12, minus 2 is 10. Now I'm just going to pick the points that are perfect so it's easy to graph. So my perfect points is when x is 0, y is -2. When x is 1, y is 1. I'm going to skip the square root of 2, 4, and square root of 3, 7, but the last point is 2, 10. So when I graph this, here is 0, -2. Here's 1, 1. And here's 2, 10. Now to write the equation, we have that x equals square root of t. We're going to square both sides. So x squared equals t. Now go to y. Y was 3t minus 2. We're going to substitute that t is x squared. And that's my equation. Y equals 3x squared minus 2. And this is in the interval for x from 0 to 2. So the first value was 0, the last value was 2.